Okay, here are the answers to the quiz on linear momentum. In the first question, mass of object A is 3 kilograms, mass of object B is 6 kilograms. First object is moving at 2 meters per second, and the second object is moving to the left, so it's -1 meter per second. And you have to calculate the total kinetic energy after the collision. But remember that because it's an elastic collision, kinetic energy before is equal to kinetic energy after. So we'll find the kinetic energy before. That'll be 1/2 ma va squared plus 1/2 mb vb squared. Plug in the numbers. 1/2 times 3 times 2 squared is 4 plus 1/2 times 6, and -1 squared is 1. When you add them up, you get 6 plus 3, which is 9 joules. In question 2, force is given as 9 newtons. The time is 2 seconds. The mass of the object is 6 kilograms, and you're asked to find the change of velocity, which is v minus v naught. And according to the formula, F times delta T is m times v minus v naught. And so 9 times 2 is equal to 6 times v minus v naught. So 18 is 6 times v minus v naught, and we're looking for v minus v naught, which is the change in velocity. It will be 18 divided by 6, that is 3 meters per second. In question 3, the mass of water is 120 kilogram per minute. So that will be 120 divided by 60 kilograms per second. So that's 2 kilogram per second. The height from which it falls is 3.20 meter. The initial velocity is 0. Acceleration is 9.8 meter per second squared. And we can find the final velocity using v squared is v naught squared plus 2a delta x, and delta x in this case is h. So that's 0 plus 2 times 9.8 times 3.2, and that is 62.72, and the square root of 62.72 is 7.92 meter per second. And then you can use the formula for force, which is m times v minus v naught by delta t. Plug in the mass per second. So remember that's m by delta t, which is 2 kilogram per second. So 2 kilogram per second is m divided by delta t. And multiplying that, you get 15.8 Newton. In question 4, mass of first object 0.1 kilogram, mass of the second 0.15 kilogram. The first object is moving at 0.2 meter per second. The second object is initially at rest, so it's 0. And you have to find v prime A. We do not know v prime B. We do not know the velocities of both. But since it says it's an elastic collision, we can use this formula. And plug in the numbers. 0.20 minus 0, of course, is equal to VB prime minus VA prime. Again, remember, it's an elastic collision, and that's why we can use this formula. And then by the conservation of momentum, you add the initial momenta together. That should be equal to the final momentum. So plugging in the numbers carefully, 0.1 times 0.2 plus 0 is equal to 0.1 VA prime plus 0.15 VB prime. That's our second equation. So from equation 1, if you make VB prime the subject, you get VB prime is VA prime plus 0.2. Take that and substitute into VB prime here. You get 0.02 is equal to 0.1 VA prime divide plus 0.15. In place of VB prime, you put the whole this, and you get 0.02 is equal to 0.25 VA prime. That's because of opening the parenthesis here and getting the two terms. Remember that. So finally, VA prime is equal to 0.01 by 0.25, that is 0.04 meter per second. In the fifth question, MAVA is equal to actually it's minus MBVB, as I will show below, but just to get the numbers, 70 times the unknown is equal to 2 times the velocity, which is 14 meter per second. So you get 70 V is 28, and VA is 28 by 70. That gives you 0.40 meter per second. Now actually the initial momentum is 0 because both the astronaut and the hammer are not moving, and therefore the initial momentum 0 should be equal to the total final momentum, which is this. And that's why when you take this to the other side, it becomes negative, and you get that formula with the negative. So I have plugged in the negative back into those equations to give you minus 0.40 meter per second. Question number 6. The masses are 2 kilogram. Velocity of the 2 kilogram is 4 meter per second. The mass of the second one is 2 kilograms, but it is stationary, means its velocity is 0. And because this is a perfectly inelastic collision, they stick together. So in a perfectly inelastic collision, they stick together. Now, using the conservation of momentum, and because they have a common velocity, you add the masses, plug in the numbers. Remember, the second object is stationary, and then add their masses and the unknown VA prime. So 8 is equal to 4 VA prime. So VA prime is 8 divided by 4, which is 2 meter per second. Now, you're asked to find the loss of kinetic energy. So you got to find the kinetic energy before, which is 1/2 MAVA squared plus 1/2 MBVB squared. On plugging in the numbers, 1/2 times 2 times square of 4 is 16 plus 1/2 times 2, and the square of 0 is 0, of course, and so you get 16 joules. That's the kinetic energy before. Now the total kinetic energy after, by the same process, is again the formula is the same, so 1/2 MAV. Remember that they stick together, so you add the masses and multiply with that common velocity which we got as 2. Plug in the numbers. 1/2 times 2 plus 2, those are the masses, times 2 squared is 4, and that gives you 8 joule. So if you take the difference between these two, you get the loss of kinetic energy as 16 minus 8 is 8 joules. Question number 7. The mass of the car is 2000 kilogram, moving at 30 meter per second. It's colliding with a brick wall, and the time of collision is 0.20 seconds, and you have to find the force. Force is given by mass times change in velocity divided by the time. Plug the numbers in to get 2000 kilogram. Take away 0 minus 30 divided by 0.20. I've just put in the units for each quantity, and that gives you negative 300,000 Newton. This is the force exerted by the brick wall on the car. Now to find the force exerted by the car on the brick wall, just take the opposite. You get plus 300,000 newtons. In question 8, the mass of the ball is 0.10 kilogram. It's dropped from a height of 12 meter. And we have to find the velocity on reaching the ground. We know the initial is 0. The acceleration is 9.8 meter per second squared. So use the formula. V squared is V naught squared plus 2A delta x, where delta x is h. Substitute the numbers to get V squared as 2 times 9.8 times 12, because V naught is 0, remember? And when you take the square root of 235.2, you get 15.33 meter per second. Now, momentum is mass times velocity. And so the mass is 0.10 times the velocity is 15.33 meter. So multiply those two numbers to get 1.5 kilogram meter per second. Question 9. Your mass is 50 kilograms, that's MA, and you're moving at 4 meter per second. Remember that your friend is not moving, is standing still, and has a mass 40 kilograms, and the velocity is 0. The question says at what speed do you move off together? So both the velocities, final velocities, are the same. Apply the conservation of momentum to get the answer, but remember, because they're together, add the masses as done before. Plug in the numbers. Fifty times 4 is equal to 50 plus 40. Adding the masses times the velocity to be determined. So that gives 200 is equal to 90 VA prime, or VA prime is 200 divided by 90. Gives 2.2 meter per second. Now onto the last question. You've got to find the total impulse. So find the impulses of each one individually and add them up. Impulse is F times delta t. So the first one is 4 times 3, first impulse. Second is 15 times 1. So that's 12 plus 15. That gives 27 Newton seconds. Thank you.